Alright guys, today we are going to have a review of Earth's weather and the atmosphere. And so when we look at this picture, we notice that we see Earth's atmosphere, and it's not a definite line. Instead, it's somewhat of a continuum, and we see the different colors here. Earth's gases are held on by Earth's gravitational pull so that they stay fairly steady. There are a few molecules that will go off into outer space, but for the most part, because of gravity pulling down, they're going to stay put. Now, as we talked about with Earth's water in the oceans, the gas in the atmosphere is also not created equal, just like Earth's oceans are not created equal. So when we look at another picture of Earth's atmosphere, we can see some of the different layering and different coloring of the atmosphere. And so I'd like to start with just doing a quick refresher on these different layers of the atmosphere. So the bottom layer is our troposphere, and if we remember, that is where all of our weather happens. That is also where we are going to have planes fly and hot air balloons fly and jets, and it's also where a lot of life's gases are found, so CO2 and oxygen. Because of gravity, the heavier gases in our atmosphere are going to be lower than the lighter ones that are on top. The next layer that we have is the stratosphere and stratosphere. And this one is important because it contains the ozone, and the ozone protects us from UV rays. There is a special form of oxygen in this layer called O3, and it's able to repel some of that UV radiation that would be able to come in. It actually bounces off into Earth's atmosphere. So it's a very unique, and it has to do with the chemistry of that oxygen. The next layer is our mesosphere, and the way to remember this is think mesosphere as meteorites. This is going to protect us from space debris. And so we're talking about meteors, we're talking about comets. Back in the day when Earth didn't have much of an atmosphere, asteroids would bombard us and leave a lot of craters. And if you ever look at the moon, it's got a lot of craters because the moon up here does not have its own atmosphere, and so it leaves a bunch of craters because it doesn't have that protection. And then the last one that I want you guys to know is one that we call the thermosphere, and this one has both the hottest and the coldest temperatures of the atmosphere. So as we talked about, usually what we say is when stuff is hot, the molecules are going to be spread out, and when stuff is cold, the molecules are going to be really compact. And in the atmosphere, it's a little bit opposite, because what happens is that when we get higher up, the Earth's gases are less dense, so there's not as many of them, and with that, we feel it as coldness. Down here, there are more molecules, and so if we're standing here and we get hit by those molecules, we feel that as heat. When we go up to like Mount Everest, or let's say we're at the top of the highest mountain or the highest skyscraper on a mountain, we're going to be hit by less of these air molecules, and we feel that as coolness, but it's not necessarily cool because of the temperature. It's because of the space between those molecules. So next, let's talk about Earth's weather a little bit. So the atmosphere is controlled and influenced most notably by sunlight and the heat that it provides. So when we have sun and we have heat, it changes our atmosphere. And one of the things is that it can influence the precipitation. So when we see like different kinds of cloud formations here, we can have low pressure systems, we can have high pressure systems. Usually when we have low pressure systems, it brings with it moisture. High pressure systems is usually cool weather. And we also notice that we have a whole bunch of directions that weather can go. In the United States, our weather goes from west to east typically, but we can also see that we can have different fronts come from all over the place. But one of the other kind of cool things is that Earth, because it is tilted at about 23.5 degree axis, is that we don't get weather that goes in exact straight lines or exact opposite lines. Instead, it kind of bends a little bit because of that tilt, and that's known as the Coriolis effect. In a planet like Jupiter, you do have those straight line winds, so you get a little bit of, kind of bending that you see in here, but we see that weather is going in certain directions. What's kind of cool is if we talk about hurricanes, which we will in a little bit, hurricanes are caused from what we call opposing weather patterns. So the big giant red spot that's actually on Jupiter is a hurricane, it's U, and this has been lasting for almost 250 years. But the reason for that is that these winds keep going opposite of each other, and they keep adding fuel and energy to it to keep that hurricane going. And as you see, Jupiter is actually covered with a whole bunch of different hurricanes because of where those weather patterns meet, and so they get a lot of swirling. If Earth didn't have the tilt, we would have a lot more hurricanes like what happens with Jupiter. Another thing that's unique about Earth is that it heats differently. So we know that in the equator of Earth, it is relatively hot. Can't see that very well. In the poles, it's relatively cold. And so what that difference of temperature does is it causes weather to also be different. And we see that with weather patterns changing. We see that with winds and how they change. So because of this difference of hot and cold, not only that, but land also heats and cools differently than water. So those things between our poles and our equator, and then land versus water, all contribute to making Earth look the way that it does. So we can have what we call local winds, and then we can have what we call global winds. So these are the global winds because of land and water, poles versus equator. But we can also have local winds, and we talked about this with Chicago. So because land and water heat differently, it not only heats the substance that it is up differently, but it also heats or cools the air differently. So because land heats faster, it also heats the air above it. Because water doesn't heat as fast, it stays cooler, we start to get those convection currents, just like what happened in the mantle. It also happens in a smaller area like this. And so Chicago is the windy city because it's land, skyscrapers, a lot of cement that heats fast. And then you have Lake Michigan, which doesn't heat as much. And so you can get this wind that's created, not only local, but also even between days and nights. So if you've ever noticed that it's most windy usually right at the beginning of the day or towards the evening, not so much at night because things start to balance themselves out. So not only does it happen at a global level, but also a local level is how we get those winds. Now let's talk a little bit about weather. So tornadoes, as well as any type of storm, the biggest thing that causes them is different types of air. So typically, you're going to get humid and warm air colliding with dry and cold air. So any combination of dry and humid, any combination of warm and cold is going to create a storm because it's going to cause a lot of condensation and a lot of energy to be put out as well. So a tornado is when you have a warm and cold front that don't meet head on. Instead, they're going to kind of meet and then start twisting. A hurricane is kind of like a tornado, just on a much larger scale. And so it is going to be added because it forms over warm water. And that's what will cause it to take place. Thunder is the noise that is caused by lightning. So not only is lightning really bright, but it also gives off a lot of heat. And the reason why thunder rolls is because there are air molecules that are colliding with other air molecules, and that's why thunder can cause echoes or the rolling to take place. So the biggest thing that causes significant weather is those warm air masses, cold air masses, dry and humid mixing with each other. So collectively, if we talk about the United States, we can get Tornado Alley. So we see Tornado Alley is here in the reddish color. We get dry, cool air that usually comes from Canada because there's a continent there. We get warm, dry air that comes from over Mexico. But then we can also get humid air that comes from the Gulf. And we can also get cool, moist air that comes from the Great Lakes. So just like we talked about on that previous slide, if you get any combination of those two, you make it much more likely to get a thunderstorm and much more likely for it to create a tornado. So these are just kind of quick recaps of what we learned. Make sure that you guys take a look at the water cycle and all the vocab that goes with it. And good luck as we get ready for our weather and atmosphere chapter test. Have a good rest of your day.